In this video, I'll be discussing the mock exam for engineering, mathematics and modeling, and I've put the first 3 questions on the board, but of course questions 4 and 5 will be included as well. And we start off with vectors, and the first question was calculate a plus 3b minus 5c, and we can do this by going through all the different directions, the I, the j and the k direction. Please note that b has a factor of 0 in the I direction. Don't let that trip you up. So for the coefficient of I, we get 5 plus 3 times 0 minus 5 times 6 is minus 25i. For the j component, we get minus 1 plus 3 times 1 minus 5 times 2, that is minus 8 times j. And for k, we get minus 7 minus 9, so that's minus 16, minus 5 is minus 21k. The second question is determine, so this was A, B is determine the length of A plus B, and please make sure that you put the vector notation above the vectors. Well, let's see what A plus B is. So that's the length of 5i plus 0j minus 10k, and the length is then equal to the square root of 25, so 5 squared plus 0 squared plus is this correct? No, this is not correct. Yes, it is correct. Plus 100 is the square root of 125, which is equal to square root of 25 times 5, so that is 5 times the square root of 5. So that makes it slightly better to read. The next question is determine the angle between vectors b and c. Well, we know that if we take the dot product between b and c, it is equal to the length of b times the length of c times the cosine of the angle between b and c, and this is the one we're after. So we can calculate theta as the arc cosine of the inner product between b and c over the lengths of these vectors, which is 1.26 radians. Well, the length of b we can calculate, so the length of b is the square root of 10. The length of c is equal to the square root of 41, and the inner product between these two is equal to minus 1. And if we plug all this in there, we get 1.26 radians. Finally, we have the cross product between A and C, and I like to use a determinant, but you can use a different formula as well, which you can also write down on your formula sheet. I use the determinant I, j, k. Then I write down A, 5 minus 1 minus 7. Then I write down C, 6, 2, 1. And then if you're using this, you calculate the determinant using the first row. So this is I times 1, minus 1 plus 14, so that is minus 13 I. Then I have a minus sign because of the minus in the determinant here. I get 5 plus 42, so I get, and including the minus sign, 47j. And the last one, k, so I get 5 times 2, which is 10, plus 6 is 16, with a plus sign for the k. So there's plus 16k, and this is my cross product. But you can also use a different formula. You might not have seen this, but this is the way I remember it. If you don't know this, just ignore it, then this is the answer. All right, matrices. We need to calculate 2a plus 3b. Now, if we multiply a by 2, then we multiply every element by 2. And if we multiply b by 3, we multiply every element of b by 3. So we get 2, 4, 6, 4, 10, 6, 2, 0, 16. Plus times 3, so that is 6, 0, 3, minus 3, 3, 0. Am I doing it correctly? It's the other way around. So it's, let me do this properly, 3a plus 2b, so we get 3, 6, 9, 6, 15, 9, 3, 0, 24. And I have the feeling I'm doing it incorrectly again. But that doesn't matter. I think we're on the right track here. Plus 2 times b. 4, 0, 2, minus 2, 2, 0. 6, 12, 4. So this is 3 times a, that's 2 times b, and then it's a matter of adding them together. We get 7, 6, 11, 4, 17, 9, 9, 12, and 28. And should I have made a mistake in either of those coefficients, then the idea is the same. B is calculating the determinant of A. Now I have a 0 here, so I'm going to expand it along the third row, keeping in mind the pluses and minus of the determinant. You can always write that down somewhere as well. And so that is 1 times the determinant 2, 3, 5, 3 minus 0 times really whatever, because it's 0 anyway, plus 8 times 1, 2, 2, 5. So that's equal to 6 minus 15 is minus 9. And here I have plus 8 times 5 minus 2 is equal to 1, so plus 8, so the determinant is equal to minus 1. And then the final question here is, can we multiply A and C? Well, A is a 3 by 3 matrix, and C is a 2 by 3 matrix. And as these inner dimensions are not the same, we cannot multiply A and C. Then we get our first set of linear equations. I take the augmented matrix 1, minus 1, minus 1, 1, 1, 1, 1, 2, 1, 1, minus 1, 4. And my aim is to get zeros here. So I subtract the first one from the first one and the first one from the third one. And I get 1, minus 1, minus 1, 1, 0, 2, 2, 1, 0, 2, 0, 3. I we'll then switch these two around because of that 0 here. You don't have to. You can also just say, well, I'm going to subtract the third one from the second one, and I end up with my 1 minus 1 minus 1, 1, 0, 0, 2, minus 2, and the last one I'll just leave, 2, 0, 3. And the book usually just stops here, and we find that z is equal to minus 1, y is equal to 3 over 2, and if and we get x minus 3 over 2 plus 1 should be equal to 1, which means that x is equal to 3 over 2. Now, we have found values for x, y, and z, which means that the solution here is the point x, y, z, and so it's a single point solution. The second one, we take the augmented matrix 1, 1, 2, 7. And I apologize, in the mock exam on Brightspace, this was a 1 and it should have been a 2. If you had a 1 there and you find a single point solution, you've done it right. But I will work it out for this one. 0, 1, 2, 10. Now, because I have a 0 here, I don't have to worry about that. I subtract the first row from the second. And we find 1, 1, 2, 7, 0, 1, 2, minus 2. And you can already see that the system is not consistent, because I have 1x plus 2, 1y plus 2z is minus 2 here, and it has to be 10 in this third row. Those can't both happen at the same time. Now, should this not be apparent immediately, we continue to try to get a 0 there, and what we do is subtract the second row from the third one, and we find 0, 0, 0, 12. And here we know it's inconsistent, so there are no solutions, because the last row says 0x plus 0y plus 0z is equal to 12, and that, this should be a lightning bolt. This cannot happen. So there are no solutions because it is an inconsistent system. All right. Then we have our question on differential equations, and I'll have to start removing things from the whiteboard for this. So question number 4, we have the following differential equation: dy dt is equal to e to the power of y times 40 minus 1. Well, this one we have to solve using separation of variables. So everything with y to the left side and everything with t to the right side. And I'm going to rewrite 1 over e to the power of y as e to the power of minus y dy is equal to 40 minus 1 dt. And now we can integrate both left and right. E to the power of minus y dy is equal to the integral 40 minus 1 dt. Well, the primitive function of this, technically we use the substitution method, but that's equal to e to the power of minus y 2t squared plus, minus t plus our integration constant. Now, I want y, so the first step is to remove that minus sign. E to the power of minus y is equal to minus 2t squared plus t minus c. Now, left and right, I take the natural logarithm, so I get minus y is equal to the natural logarithm of minus 2t squared plus t minus c. And finally, I move that minus side, I multiply left and right with minus 1. Y is minus ln minus 2t squared plus t minus c. I had an initial condition where y0 is 0, and let's fill this in. in here we get y of 0 is minus the ln of, well, minus c. And we know that the natural logarithm of 1 is equal to 0, which means that c is equal to minus 1, and that the solution here is y of t is equal to minus the natural logarithm of minus 2t squared plus t plus 1. And this is our final answer. Now we also have for part C is we have a differential equation with a fourth order polynomial. Now it doesn't contain all the terms. For example, it doesn't contain a term in x squared, but if we have a fourth order polynomial, then our particular integral, and I think it was in x of t, no, sorry, it was probably y of x. But if it's a fourth order polynomial, we try a complete fourth order polynomial. So you do not leave out any of the terms. So it doesn't matter if it's just x to the power of 4 minus 1. You take the all the powers of x right up to the constant. That leaves us with the modeling question. And the modeling question is, we have some kind of mass. We have a mass m of 2 kilograms. We have, so this is the question 5. Let's start this over. Question 5, the modeling part, where we have been given a couple of bits of information. We have the mass is 2 kilograms. We have a spring force, Fs, which is equal to minus k times x, where we have k is 150 kilograms per second squared. We have another force, some kind of friction force, which is equal to minus b times v, where b is 40 kilograms per second. And we have two initial conditions, x0 is equal to 0, and the first derivative is equal to 10, and that'll be meters per second, and that will be meters. Well, the first important thing is to note that the acceleration is the first derivative of x, and the acceleration, sorry, the velocity is the first derivative of x, and the acceleration is the second derivative of x with respect to time. And what I always like to do next is draw a free body diagram. This is my positive x direction. We have a spring force here, and we have some friction force there. And now I write the second law of Newton. The sum of the forces is equal to the mass times acceleration. We have two forces here, minus F spring minus F friction is equal to m times d squared x dt squared, because ultimately we want a differential equation in x. We plug in our constants and we'll move these two to the other side, and we get m d squared x dt squared is equal to the spring force, plus the spring force, k times x plus b times dx dt is equal to 0. I usually put these two the other way around, and I will swap them now. So we get 2 dx squared dt plus 40 dx dt plus 150 x is equal to 0, and we get the differential equation by simply dividing by 2 here. And as it's equal to 0, that of course is fine. So we get d squared x dt squared plus 20 dx dt plus 75 x is equal to 0. So before we continue this, just a quick recap. So we are given two forces. We know that there's a positive x direction. The forces will be, well, negative as they, well, we're pointing that way because they are negative. The key point here is the second law of Newton, where we put in our forces. We know that the velocity is equal to the derivative of the position, and the acceleration is the second derivative of x. We plug this all in and we end up with this differential equation, which is a second order linear differential equation with constant coefficients, and it's also homogeneous. So to solve it, we calculate the auxiliary equation, which is lambda squared. The book uses k, but I use a lambda. It doesn't really matter. Plus 20 lambda plus 75 is equal to 0. Now you can use the ABC formula for this, but this is lambda plus 5 times lambda plus 15 is equal to 0. So lambda is equal to minus 5, or lambda is equal to minus 15, and our solution is x of t is equal to some constant e to the power of minus 5t plus another constant e to the power of minus 15t. And the next question is solve this general, well, find the particular solution for this set of initial conditions, which is fine. So I write down the, actually, let's get rid of this, the derivative of this function, which is minus 5a e to the power of minus 5t minus 15b e to the power of minus 15t. And I plug in my values here. So x0, I put t as 0, is equal to a plus b, which is equal to 0, because that's my first initial condition. X prime 0 is equal to minus 5a minus 15b, and that is equal to 10. Well, we can use substitution to find our values. The first one, let's see, a is equal to minus b. I put minus b here, so minus 5b minus 15b, so that is, sorry, I have a minus sign here. Minus 5a is equal to 5b minus 15b, so that's minus 10b is equal to 10, so b is equal to minus 1. So a is equal to 1, and our particular solution is equal to e to the power of minus 5t minus e to the power of minus 15t. And the last question of this part is to draw a bit of a graph from 0 to 1. And my recommendation would be to select a couple of points. You can take 5 points, you can take 6 points. It starts at 0, and we know it's because these have negative exponentials, it will decay to 0. It turns out there is a bit of a bump here, and it will decay slowly away. But my advice would be to get a couple of points using your calculator, and then to draw a line. And should you not find this bump here, then that is fine. Usually we'll use a computer to plot this anyway. The second part is where we change the spring constant to 200 instead of 150, and we get a different differential equation. Again, using the same method as we did before. The only thing that changes is k is no longer 150, but it is 200, and we find instead of 75 here, we find 100 there, and we find dx squared d squared x dt squared plus 20 dx dt plus 100x is equal to 0, and we solve it in exactly the same way using the auxiliary equation, which is lambda squared plus 20 lambda plus 100, and that should be equal to 0. And again, you can use the ABC formula or see that this is lambda plus 10 squared is equal to 0, and we find lambda is 10 or lambda is 10. We find the same value twice, but then if we know that they are lambda 1 and lambda 2 are equal to each other, we find that xt is some constant e to the power of minus 10t plus bt e to the power of minus 10t. So we add that t here because we have two identical roots of our auxiliary equation. So this is the general solution. We use the same initial conditions, but first I will differentiate this. So x prime of t is minus 10a e to the power of minus 10t, and here this is something which often goes wrong, is you need to use the product rule to differentiate this. So this is plus b e to the power of minus 10t minus 10bt e to the power of minus 10t. So there you get two terms instead of one. This is a common mistake. We fill in our initial conditions. x0 is a plus, and this is where I usually get tripped up. I have to put that 0 in there as well. So it becomes just a, which is then equal to 0. And x prime 0 is minus 10a plus b, and that should be equal to 10. But as a is equal to 0, we are just left with b is equal to 10. And our solution, x of t, is equal to 10t e to the power of minus 10t, as a is 0 and b is 10. And I think this was the exam at a very, very high pace. And of course, I can do this very quickly because I have all the answers here. If you do this in an exam, this is it will take on average around about that 100 minutes. Now, if after this video you have any questions, feel free to email me, WhatsApp me, and there'll be a question hour at 9 o'clock on Tuesday before the exam. Thank you.